Greetings, Saintsmen. This is lesson 8.1 regarding similar polygons. Um, when we're talking about similarity, it's actually a mathematical thing, not that it just appears to look like something, but what it means is that there's a proportion that consists. So when we define proportion mathematically, we actually start to talk about ratio. So here's how we actually can express ratio. Um, we have to be careful. If we can say, look at a division of two quantities, but how that actually is expressed, right? Um, so like for example, A to B is one way that we would say that, right? Of quantity A to quantity B. How many of quantity A for every single amount of quantity A, there's that many for quantity B. Also listed, sometimes they'll write it like this: A colon B, which is also meaning A to B. And you'll actually see it written this way too as a fraction, but you have to be careful here because this is not um, like division or percentage. And here's what I mean. Um, if you went to a party, for example, on a Friday night, and the ratio of boys to girls is 2 to 3. Okay, what that means is that for every two, and we'd express it like this, right? 2 to 3. But for every two boys, there's 3 girls. Okay. But it's not going to be division or percentage. For example, that doesn't mean 2/3, right? 2/3 would mean that we have 66% of the uh or 66.7, right? 66.67% of the participants are boys, but they're not really, right? Because there's more girls than boys. Really, the percentage there is going to be about 40%, right? Because it's going to be um, for every 5 people, right? 2 are boys. Okay, so that would mean that the 40% of the participants are boys. All right. This is actually um, far more favorable in terms of attending, if you're desiring to attend a social gathering where there are more female participants than male participants. So um, you wouldn't want to think of it that falsely that that's only a third of them, right? Because it wouldn't be a third of the participants wouldn't be boys. That just wouldn't be accurate. Okay, there still is going to be more girls than boys, but I need to make sure that that's accurate. So we're going to take a look here. Oops. Let's see here. Oh, goodness gracious, my silly pens having issues again. Here we go. There we go. Fixed it. Let's take a triangle here. Oops. Hmm. Let's be able to circle this. Oh, there we go. Create a second one here. Um, Now, what this feature on the software does, it actually creates proportional figures. Okay. And here's what it is showing is that these are going to be similar polygons, and I'm going to give you guys some dimensions. So we have triangle ABC, right? This polygon is going to be a triangle. And we have JKL with 21, 27, and 36 as my quantities on triangle ABC. And then 28, 36, and 48 as my quantities for JK or for JKL. All right. So when we have similar polygons, what that means are proportional. So all corresponding sides have a ratio and corresponding angles are actually going to be congruent. So it's this, okay? Um, it means that if I'm going to give a similarity statement here, okay, which is that we have triangle ABC is similar to triangle JKL. Okay, this is my similarity statement. And this is what the stuff means. For example, this right here, this symbol means similar. It means there's a proportion for each of these. Okay? Now, the similarity statement, like a congruence statement, gives you your corresponding parts. For example, AB and JK are going to correspond to each other. So AB is 27, JK is 36. Okay? So this is how I'm going to get my scale factor for each of these. The scale factor works as follows. So for example, we had AB to JK, which is going to be the same as proportionally BC, right? Second and third to KL. Okay. Which also then gives me AC to JL. Now, each of those corresponding parts, right? Now we have the angles A and J. What it means is that these two are going to be congruent. Moreover, B and K are congruent, right? The second letters, and C and L, right? Or my last two my last two letters. So those angles have to be congruent. So the sides are all proportional in the same scale factor. Let's go check it out. So we had, for example, 27 to 36, and if we reduce that, both are divisible by 9, right? Which is 3 to 4, okay? Or, as we put before, 3 to 4, or what we like is with ratios or scale factor, we like to put it as 1 to something. We need to like to have a clean multiplier. And what it does is when we do that, for example, like 1, 2, and whatever we do as our scale factor, right? We divide both of these in this case by 3. Okay, 3 divided by 3 is 1, and 4 divided by 3 is 1 and a third, right? Or 1.3 with the repetent bar above. Okay? Which is great because what that means is that for every one thing, we have 1.3 of the other, right? So, and again, all these ratios have this same, or all these sides have the same ratio when similar. Check it out. So we did AB to JK. Let's do BC, right? That's 36 to 48, okay? Which BC to KL. Again, arithmetically speaking, 36 to 48. Both divisible by 12. 36 divided by 12 is 3. 48 divided by 12 is 4. So no surprise, it's 3 to 4. Or AC, right? First and third to JL, first and third. AC was 21. JL was 28. Both of those divisible by 7. And again, 3 to 4. Of course, right? 3 to 4, 3 to 4. All right. So sometimes we'll be asked if something is similar, but when it is, given that it's similar, we'll actually be able to solve a proportion. So let's take the following diagram. Are you guys ready? See if I can. This is kind of a tricky one to. Oh goodness gracious! I'm gonna have to turn that feature off. All right. So let's do a little bit of pretend that I drew very straight figures now that I don't have the software fixing it. But it was trying to snap that figure too. So we have GHM and HKL. Okay, and we have the following dimensions. GH is 10. We have HK is 15. We have KL is going to be the variable X. Okay. HL is 27. HM is 12. And GM is 18. So here are your directions. We have that given if triangle GHM is similar to triangle HKL, and you find X. Okay? Now, what is X? Well, X is KL, right? That's second and third. So it's going to be HM to KL, right? Is going to be, and I can go either one of these, right? Let's go GH to HK, right? Because I had HM in the top, so it's got to be GH, right? Part of this first triangle. And then here we go, my second triangle, right? I have KL, and the first two is HK. So now I'm going to substitute and solve, okay? So HM is 12, KL is X, GH is 10, and HK is 15. I take a cross product, right? So I'm going to have 12 times 15, okay, which is 180. You guys remember this cross product like this? Okay. And that's going to be is equal to x times 10, which is 10x. Divide both sides by 10. 180 divided by 10 is 18. That's x. So that is the value for kale. Okay. Moving on. Next. Another triangle. Oh, you know what? I can actually let my software fix this one for me. Be better for all of us. Okay, I have S, Q, T, R, and then these are both 36. Okay, I have another triangle here. I have V, yikes. V, Z, oops, get away from me here. U, W, and then this corner right here is 12, and then each of these is 16. Okay, so here's your given directions. In the diagram, triangle UVW is similar to triangle QRS. All right, that's given. So we're going to find the length of, now what type of line is ST? Think about this guy, okay? ST goes from a vertex to a side opposite and it bisects it, right? These two are congruent. When you do that, it's a special type of line which is called the median. You guys remember that from the first semester. All right. Now, medians are going to be proportional in any other way that we'd have for a, and as well as the parts, in any other ways we have for any triangle, right? So let's say we have WZ, which is my median, which will be proportional to um, ST. Okay, those are my two medians. So then now I just need, I could take the entire side that makes up the median, right? That's opposite that angle, and I'm going to make those my proportional sides. So I have UV, which is 12. Sorry, WZ to UV. And then ST to QR. So WZ have is 12. UV is 16 plus 16, which is 32. ST is what we're solving for. And QR is 36 plus 36, which is 72. And of course, we're going to take our cross product, right? 72 times 12, according to your calculator, should be 864, and that's equal to 32 times ST. And we divide both sides by 32, so we will get 27 is equal to ST. And that is our answer. Okay, next. Your neighbor has decided to enlarge his garden. The garden is rectangular. Not a lot of imagination there for the neighbor. With sides of width 6 feet and length 15 feet. The new garden will be similar to the original. Now, it's not that it like resembles it. That's not what it means. It was similar. It means mathematically, but it will have a side length of 35 feet. And we want to find the perimeter of the new, of the original and new gardens. So, remember how we do perimeter. 6 and 15. Okay. So those are my length and width. So we're going to have our perimeter of our original, which is going to be 2 times my length, or my width, plus 2 times my length. 2W plus 2L, right? Because they're all 4 sides. So 6 plus 15 plus 6 plus 15, or 6 plus 6 plus 15 plus 15, or 2 times 6 plus 2 times 15, which will give me 12 plus 30, which is 42. Okay, so 42 feet. Cool. That solves one of the things, right? Perimeter of the original. Now, we need the new garden. Now, if we take our scale factor, and this guy has a length 35, this guy's got a length of 35, it will go 15 to 35, will be my scale factor of 3 to 7. Okay? And that's going to go from old to new. And the thing that we need to know is that we have perimeters have the same ratio. Should make sense because it's a linear length, right? So we'll go old to new, which is 3 to 7. The old one has a perimeter of 42, and then now we need to find P for the new one, okay? So P7 new. And then we have P times 3, so 3P is equal to 7 times 42, which is, according to your calculator, 294, which is divisible by 3. 2 plus 9 plus 4 is 15, which is divisible by 3. So the new perimeter is 98 feet. Okay? All right. So our perimeters, because they're linear, will have the same ratio and obey the same scale factor. Now, I'm going to show you guys something here. It doesn't work that way for area. Area has a squared scale factor. It's pretty cool. So check this out. Let's take a couple trapezoids here. Okay, so let's get this guy. Oops. Oh, goodness gracious, guys. I'm struggling here. All right. Or as you guys would say, I'm selling. All right. So here are my two factors. KLMN. PQRS. So only given two things here. One, this side is 7, this side is 21. Second one is that my area here is equal to 84 meters squared. And we want the area for this bigger polygon PQRS. Okay? So, being given if KLMN is similar to PQRS, then the area, oops, let's clean that word up. That was not very well written. The area of KLMN to the area of PQRS follows the following. It is a squared linear factor of any of the two corresponding sides. In other words, KL is the first two letters. So KL, PQ is the first two letters. Oops, it's RQ. Let's fix that. That's a squared scale factor, right? Or LM to QR. Or MN to RS. Or KN first and fourth to PS squared. Okay? So it works like this. It's not just 7 to 21 as 1 to 3 as your scale factor, but it's a 1 to 3 squared. So if I go 84 on this side, right, to whatever this area is going to be the first one, 7 to 21 squared. Okay? Or I take this is actually, and I hate saying easy, but again, do you know who this is easy for? We talked about this. It's easy for the calculator. Calculators are going to do the heavy lifting here, right? 7 squared is actually a very easy problem for the calculator, right? And it's, I think, not that labor intensive for you just to use your fingers. Yeah. Okay? 49. 21 times 21. I mean, I know that it's 441, but I mean, the calculator for sure knows it. And so just click, click, click. Boom, you have 441. Now, it's going to continue because you guys already see where we're going here. We got to get a scale. We got to do a little cross product. So, 84 times 441, calculator is great at this problem. 37044 is equal to 49 times the area, or 49a, divide both sides by 49, and I have 756 as x, which it means it's 756 meters squared, and that's my units. Okay? So, gentlemen, there you have it. All right, gosh, keep struggling with that. There you have it. I will see you guys. Come see me during my office hours if you have any questions.